All right.
Why are you clapping, Kelly?
So we're just going to do some examples from chapter 14. Just do a few more, just a little more practice together. So you're drawing cards from a standard 52 card deck, Kelly's favorite thing. One card is drawn. What is the probability that it's an ace or red? There is more than one right way to do this. Let's talk about all the different ways that we could do it. So we could just think about, because it's a small enough set and we actually know about the individual members, we could just go, well, how many of them are either red or are an ace? How many of them are red?
Half.
Which would be
26.
26. Plus, how many other aces do we have?
4.
3.
Oh, other.
Oh,
yeah.
You have 2 non-red aces.
Oh, yeah.
So that would be 28 out of 52. Let's see. Those are both divisible by 4, right? 7 over 13, whatever the heck that is.
There she is.
0.53846.
Okay. So how else could we do this? Because sometimes when you're trying to find all the things, it can go wrong, right? So what else could we have done?
Skipper.
Well, we could have done. Thank you.
You're
She has a note. It's all
She's
good.
a ukulele. We didn't know ukulele.
Of course, there's no time on it, so it could have been any time. I'm just teasing you. I'm just teasing you. All right. So what's the probability that it's red?
5.
The real question is, where did I put this?
Uh-oh.
That's not it. No. Yes. I have papers in too many places. There you go. You're welcome. So what's the probability that it's red?
0.5.
Yeah. Or 1/2, whatever. What's the probability that it is an ace?
4 out of 52.
Which reduces to 1/13.
Yep.
1 out of every 13 cards. But if we do that, we've double counted, right?
Yep. Yes.
So we need to subtract. How many of them are both red and an ace?
2.
2 out of 52, which is 1 out of 26. So let's see. This would be 13/26 plus 2/26 minus 1/26 is 14/26, which is 13. Oh, excuse me, which is 7/13.
Oh, so we arrived at the same conclusion.
Yes.
Though the one way was much shorter.
Yes, if you can easily count them.
Yes.
So, but what happens a lot of times is instead of being given counts, you might be given percentages, and then that makes it a little harder. Okay? But that's why I wanted to do this with cards, so we can go, oh yeah, those two things agree with one another.
Wait, 5385. Yo, calculate.
It is. You looked at her
Oh my
calculator.
god, I'm a genius.
You looked at Kelly's calculator.
I guess.
All right, so 2 cards are drawn without replacement. What's the probability that they are both aces?
Whoa.
Kind of low.
So what's the probability that the first one is an ace?
Low enough.
4 out of 52.
4 out of 52 or 1 out of 13, take your pick.
She going fast. She going fast.
What's the probability that the second one is an ace if the first one had been an ace?
3 out of 51.
Yeah, times 3 out of 51. So this is the probability that we get an ace times the probability that we get an ace given that the first was an ace.
That is quite small.
So that's going to be, yeah, that's going to be really, really small. 12 over 26 something. I have no idea. Pardon?
2652.
2652. Thank you. I was in the ballpark.
0.06.
0.00452.
Okay.
Incorrect.
But 4 and 2 add up to 6, so you were close.
Yeah,
It's-
that's how it works.
It's Lily logic.
Yeah.
All right.
Put 3 L's in front of that.
5 cards are drawn without replacement. What's the probability that they are all hearts?
Oh.
13.
Out
Out of 52.
That's for the first one.
Times 12 out of 51.
Times 11 out of 50. Times 10 out of 49. It's going to be quite a small number, I assume.
0.8 times 10 to the negative
What?
5.
She did size.
Negative 4.
You're basing this off no logic, so let's stick with your
All the logic.
Wait, why is that?
Wait, 1, 2, 3.
25?
No, to the negative 5. 10 to the negative 5.
Oh, that should be 11.
0.8 times 10 to the negative 5.
10, 9.
darn and no,
This is my official guess.
Your official
It's
Yes.
2.4 times 10 to the negative 4.
That's like close enough, TBH.
Not really.
That's like almost there.
So 0.00024. 0096. 03.
Dude, that dude yelled at me like 2 seconds ago.
Oh, really? Why?
Well, he wasn't actually yelling at me. He was yelling at his friend behind me when I thought he was yelling at me. So I like yelled back, but it wasn't like yelling.
No, you did not.
All right.
It was like, it was
Let's go on to
respectful.
part D. If I draw one card and I tell you that it's red,
I said, what do you mean?
this one is pretty simple to just work out in your head, but we're going to work out why it works out that way to verify our other formula. So if I draw one card, I tell you that it's red, what's the probability that it's a heart?
0.5.
Yeah, that's pretty simple.
Cool.
0.5.
So what if we did it, the probability that, oops, I'm in the wrong place.
Probability that oops.
So the probability that it's a heart, given that it's red. Let's use that formula to verify that this works, even on simple ones.
Look.
So that would be the probability that it's a heart and a red divided by probability that it's what?
A red?
A red.
Yeah, that's the part that you got to get right
I
on
don't like
this.
that one.
PR.
Puerto Rico?
All right, so what's the probability that it's a heart and it's red?
13 out of 52.
Yep. 13 out of 52. Divided by, what's the probability that it's red?
21 half.
26 over 52. It's actually easier if you do it that way because then the 52s cancel and you get 13 over 26, which is
0.5.
1 half or 0.5.
Oh,
5. Draw a red card. Draw a spade. Independent. Disjoint. Both. Or neither.
All right, so now we get to some interesting questions about independent, disjoint, both, or neither.
Yeah,
It can't be both.
Why not?
because
That's-
it just doesn't.
There are
It's-
no-
If
Nothing
two
But
is-
you
things,
don't know that.
yes, we actually
Nothing
do.
is- Nothing is both.
You can't say that it won't ever happen.
No, we can.
Yes, we can.
No.
In fact, we did.
But we can.
If two things
We
are
already had this conversation.
if the two things are disjoint, then one happening precludes the other one from happening.
Precludes.
But
No.
Get precluded.
what if you just flip it over one day and it's red?
That'd be wild. It's a miracle. Divine
Flip
intervention.
what over one
the
day and it's
card.
red?
A spade. A red spade.
Yeah, exactly.
Then
That's
they
not what
are.
we're
Then they're no longer disjoint.
I'm just
Congratulations.
Thank
That's Lily's
All right.
Thank you.
So
Writes it down.
a red card and a spade. So to figure out if they are independent, we will do what's the probability of drawing a red card given that it's a spade? Or we could do spade given that it's a red card. What is that probability?
0.
That probability is 0.
See, I'd get that wrong because I don't know what it's made.
It's the little shovel.
The sharp one.
The shovel.
The sharp one. So it doesn't look like a shovel.
So
Is the club
what's the
one
probability
also
that it's a red? The club one's puppy
1 half.
tracks.
what?
Puppy tracks. Have you never heard a little kid say that?
No, it looks like a clover.
No.
Yeah, it was Raven.
I
No.
actually knew a kid
Look at
that
it
would go
sometime.
to the field
Okay.
and he would
Look
eat-
at it.
and he would eat
So,
all of the clovers.
Are these independent then?
No.
I thought you asked about a real life.
Oh.
This is real life.
Because
They're not the
It's
same.
probably the
they're not the same.
1/2 doesn't equal 0.
Independent.
So, no,
So it would be,
that's out.
well, so they're not independent. Are they disjoint?
I don't know.
Yeah?
So to be disjoint,
No. Yes. I don't know. You got me guessing here.
right? So since the probability that it's red, given that it's a spade, is 0, that means those two are disjoint.
Okay.
Oh, I crossed it out. And put but if both, it's disjoint no longer.
All right, let's try this one. Are drawing a red card and drawing an ace independent, disjoint, both, or neither? Well, what's the probability that we have drawn a red card given that it's an ace? And it really doesn't matter which way you go on that.
2 out of 52.
2 out of 4.
2 out of 4. Given that it's an ace.
They're gonna be independent.
Now, let's go ahead and do it by the formula. The probability it's red and an ace divided by the probability that it's an ace. So what's the probability that it's red and an ace?
2 out of 52.
2 out of 52. What's the probability that it's an ace?
4 out of 52.
4 out of 52.
Yeah.
So that's a half,
Yeah.
which is what we reasoned out without the formula. But again, I'm just trying to give you some practice with the formula in places where you didn't have to use it. So what's the probability that it's red?
1/2. That means they're independent.
That means that they are independent.
Woohoo. Circle that
All right. Are drawing a face card and drawing a king independent, disjoint, or neither? Both or neither, right? We know it's not both. But I wanted that to be in the question because I wanted us to talk about it. All right. So what's the probability that, which way you want to do this one? It doesn't really matter.
face card given its king.
That you've drawn a face card given that it's a king. That feels a little strange. Let's go ahead and
King
do it.
face card.
100%.
So the probability that it's a face card and a king divided by the probability that it's a king. Well, the probability that it's a face card and a king,
4 out of
I mean, not 1.
30. Wait, how many cards are in the deck?
52.
2.
That.
Same as the number of weeks in a year.
I totally don't know that one.
I definitely
Now you
know it's
do.
56.
That's 1.
Yikes.
I didn't know I.
I did know, actually.
So what's the probability that it's a face card?
1.
Not 1.
Oh, wait, sorry.
It's not 1.
It's 3 times 4 over 52.
So that'd be 12 over 52.
That's not 1.
So these are not independent.
Cross that one out.
Could they be disjoint?
Maybe.
They could.
So if I draw a king, can I not draw a face card?
No.
No.
No. So they're not disjoint either. And I just, for an explanation on that, I usually write kings are face cards.
What if they're not? What if one day you
One day you flip around, it's not a
you
face.
flip
Okay.
around and it's not a face
All
card?
right.
It's a king, but it doesn't have a face.
All right. So let's go on to the back.
So it is.
So, a geometry class at a local high school is observed on a particular day, with the results shown in the table for sex and attire.
Nice. Sounds like a lame.
That sounds horrible, doesn't it? I'd like to buy one of these. What is that going to cost me? Sex and attire. All right.
It reminds me of that one time when you talked about like your nephew or something, and you were like, he has a terrible problem. He's a liberal, and you like paused for a minute before you finished the story.
I don't remember that one. Although it sounds like something I would do. All right. So, what's the probability that a male wears jeans?
Are they skinny?
What?
Because if they're skinny jeans, then 0.
So,
12 out of 34.
it's the probability that they wear jeans given that they are male, right?
Oh, wait.
Wait, why wouldn't it be 12?
So it'd be 12 out of 17?
Oh, the total.
Oh my
Oh my god.
So you have to be careful on the wording.
That's not the total.
Yeah.
God.
If I said, what is the probability that they are male and wear jeans?
If they're a male that wear jeans.
Yeah, it's the words are a little squidgy on this.
1/3. 12 divided by 36. 1/3.
So is it this one or is it this one?
12 or 17.
For total.
Jeans and male would be 12 out of 36. Okay. Do you understand?
Yeah.
Yes.
So the question is, how do we interpret the words for this?
That's what I'm
Because that can be difficult.
We're
That.
going out of males.
How
Probably that
many?
A male. We're
Yeah.
not considering anyone else.
Yeah, we're only considering males. Since we have only considered males on this, it is this,
That is.
not this.
I want more representation. Petition to change the second one to female.
Position sign.
2 for I.
Someone wearing females is male? That's a little weird.
So, what's the probability that someone wearing jeans is male? We have limited it to the people who are wearing jeans,
12 over 20.
so that's going to be 12 over 20. The probability that someone is wearing jeans given,
48.
oh, sorry,
3/5.
I did that backwards,
Point. 60.
that they're male given that we know that they're wearing jeans. So that's 12 over 20. So that's what, 60%?
Yes. Look.
Yeah, she stopped to give me some drugs.
She's your plug.
No.
All right. So, are sex and attire independent? And again, probably not, but that's another story.
Got it. Okay, you're done.
All right. So,
Yeah.
Yeah. It's your dad.
since we've already done some of this,
He's a type of.
let's go ahead and let's keep this one because it came out to be so nice.
Okay.
Oh, okay.
So, if this was independent, the probability that they are male, given that they wear jeans, needs to be equal to what?
Probability that you're male.
Probability that they're male. Well, let's see. We know that this is 60%. The probability that they're male, yeah, I'm pretty sure that's
No.
not 60%. It's 17 over 36.
Not 16. 0.47222222222222.
2-2.
There might be a little bit more twos in there, but
So,
That's not equal.
no.
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 there's a lot of ways to show right exclamation points.
If they're wearing jeans, they're more likely to be a male than the percentage of the proportion of males in the entire population.
Just really like how it's jeans and then other.
Yeah, what is the
So,
other?
like, all other alternatives.
Could be none.
Could be corduroy.
And-
Oh.
Ev-
Whoa.
Well.
in the time.
I would imagine that if you went to a typical public high school, at least one that doesn't have a completely open dress code where you can wear absolutely anything you want, that students probably a little over half would be wearing jeans.
Or fun, like
Not on the same page. Never mind.
Fun would go with
Even if it's flannel, even if it's like 90 degrees.
Well, flannels are
All right.
Any of his many flannels.
But it says show this in more than one way, so let's do it another way. So since Lily really wants females to be involved,
My bad.
Alright.
let's
Female
do
rights.
the probability. Do you want to do other given that it's female or female given that it's other?
female given that it's other.
All right. Female given that it's other.
Emphasizes the woman.
We need to
Flow.
check, is that equal to the probability that they're female?
Most likely not.
So female given that they're other is 11 out of 16. And the probability that they're female is 19 out of 36.
I doubt those were the same.
Oh, I feel like they might
What
be.
if it is?
But what if it is? What if one day you put it in your calculator and it comes out the exact same number?
It's not.
0.68 and 0.52.
Today's not that day.
So these are not independent.
I refuse.
You got Lycia?
Dude, didn't you put his dandruff on someone's foot the other day?
Females are more likely to be wearing something other than jeans than there are proportion of females in
I thought
general.
you shed and then like flipped it.
All right,
Ew.
Contaminated everyone.
let's look at another one of
Oh,
these.
look, Lily Women.
All right,
You're
shh.
killing women? Dude.
That's sexist.
Dude, not cool.
Ow.
But not very many.
My hips.
Sexist! Just sexist!
You know, ovarian cancer is very sexist.
You're canceled. Dude, do you know that AIDS is
Do you know 100% of people with ovarian cancer are women?
100% of what?
People with ovarian cancer are women?
Wait.
But do you know that that's not true for breast cancer?
Because
I
men
do
have
know that. Yeah. Got
Yes.
it. Right on the nose.
prostate. Never mind.
Mine
I thought there's a type of cancer that was like
Prostate.
we're the men. I couldn't think of it. I thought it was
There's
like,
Lance.
never mind. Oh my god, Lance.
Do women have a prostate?
Yeah,
But
it's in our throats though. It's not like.
Lily, what?
okay.
Excuse me.
At this point, we're just going to move on.
I'd like to clarify that that's not what I meant.
I don't know what you meant. I'm just moving on. All right. Ovarian cancer, though dangerous, is very rare, afflicting only 1 in every 5,000 women. A new highly sensitive test is developed that correctly detects the presence of ovarian cancer in 99.7% of the women who have the disease. Unfortunately, the test also gives false positives of about 5% of the time. To determine the probability that a woman who tests positive using this method actually has ovarian cancer.
What do you think is worse, giving fake positive or fake negative? Like you get worried that you're gonna die?
We talked about
A
this.
fake negative is much worse, in my opinion.
Yeah, that's true.
A fake positive, you can do the test again,
But if it's a negative,
or you can frequently follow it up with something else.
Like, oh,
But
yeah,
a,
I don't
but a
have
fake negative, I'm fine, and then tomorrow I'm dead.
Well, I mean, at that point, what are you gonna do about it? Like, you're gonna die the next day. Nothing's gonna help you.
Well, they could just like shoot some stuff into you and you're fine.
All right.
Yeah, get some meth.
So we want the probability
that's Brunel. You just let Brunel do
that someone actually has ovarian cancer. So I'm just going to put C, given that they've had a positive test. Shh. Yeah, it's a plus. All right, I'm going to make a table. So actually, even before I do that, I'm going to do, that's the probability that they have cancer and have a positive test divided by the probability that they have a positive test. So those are the two things I need. So I may not need to get every single value in the table.
But it's fun food.
No, it's not.
But it's complete.
Especially with the Venn diagram. We don't like
Okay. Cancer's not spelled right at the very end.
Insert.
Conser.
This was that late July.
Thank you.
Convulsor.
The kick thing.
You don't joke about that. That's a medical condition.
All right. So we're going to put cancer, not cancer, positive, negative. It only affects about 1 in every 5,000 women.
Bruh. You're all kids.
So that'd be 1 5,000th,
That's small.
which would be 2 10,000ths.
I'm guessing it's 2 times 10 to negative 3.
Are you gonna do this out of 10,000?
Four.
No. No, I don't want it. One,
Zero.
two,
Put on another 0.
See, tenths, hundreds, thousands, 10,000ths.
2.
Yeah, my phone's right.
All right, so not cancer is the complement of that, so 0.9998.
I don't like that.
What is like you?
Hey.
All right, so notice it says it correctly detects the presence of ovarian cancer in 99.97% of the ones who have the disease. So these are the people who have it. Out of those, it's going to find it 99.97% of the time. What do we do with that, and where do we put it?
Top left quadrant.
Yep. And what do we do
Really
to?
small number.
Well, how do we get that really small number?
Well, you take that much of that number.
So we're going to multiply this
Zero,
number
yes.
times this number.
Yes.
Okay.
That much of that number.
So 0.0002 times 0.9997. Notice that's the top part of what I want.
Whoa.
Yeah.
So that's 0.0002 times 0.9997 divided by, so I want the probability that I get a positive, so I want this number. Well,
False positives.
pardon?
False positives. I don't know. I assume that's where you're going.
Yeah, I want false positives. That's what I was pointing at. So the question is, how do we find that? I'm sorry, I'm having trouble hearing you.
0.05.
Times
How did we get 0.05?
5% of the
Great
time.
question. I really don't know.
All right, so 5% of the time we're going to get a false positive. I was just asking, where are you getting that from? Times 0.9998.
Do they cancel out? Oh no.
They're not the same.
No, so to get the probability of it being positive, I need to add these two pieces together, right? Well, there's no point in writing it into the table. I can just write it down here. 0.0002 times 0.9997
Your dad from the Midwest.
No, my dad's from the inner city.
plus 0.05 times 0.9998.
0.003999959999.
So
That's a tongue.
what does it come out to be?
0.003999959999.
997? I don't know why. I think I got 8, but I may have
No, you're probably correct.
I may have rounded someplace.
I can do
No,
it.
I think I did it wrong actually. I think I put it in the
So-
7 for a 9.
Notice that's less than 0.4%. So if you get a positive test, there's only a 0.4% chance that you actually have it. Which is why some of these things that are highly sensitive aren't used.
No, I got what you got.
The 0.99 whatever.
Well, I got 0.00398366668.
Oh, that's what I
That's
got.
what I got.
That's close.
Okay,
Lily would say.
So you can see, although this is really good at detecting ovarian cancer, it's not really good at telling you that it's not there when it's not there.
It's like a heart attack.
Okay?
In what way?
Any other questions about this?
Old people could get scared.
Old people could get scared.
Well, young people are less likely to have heart attacks.
Having been alive less long and all.